You got it? All right. So, just to begin, homework 9 is due on Monday. We'll talk about the last piece of that puzzle today with bundles and budget limits, and the project on Friday the 17th. Any announcement questions? I'll draw your attention to the fact that we're now in chapter 12 of the book. So if you're following along, which I think is a real healthy habit, to glance at the textbook and see how the book author is phrasing things and what kind of explanations and examples are in there. I think it's just a really good supplement to make sure that you understand the concepts and get a little bit of extra practice. For most students, it won't be enough just to do one in-class exercise and then expect to master the material from having practiced it one time. I think in most cases you'll need to get some additional reps before you really are able to understand and retain those details. So keep that in mind. All right, so today we're talking about budget limits, bundles, and capital rationing. Before getting into it, I wanted to clarify one thing from the applicable homework problem. So this is the assignment that's due on Monday I'm talking about. And in the first part of that problem, I ask you to perform a present worth analysis. And so this is a problem where you have lots of different options. You're thinking of investing in your brother's business. And he's got a variety of ideas that he thinks would increase his revenue. These are not mutually exclusive alternatives. And in the past, when you had alternatives that had different useful lives, if you're going to pick from among those alternatives, if you're going to pick one from among those alternatives, then you had to do different types of analysis, different techniques in order to make them last the same study period. Do you remember when we did least common multiples? Do you remember when we did early termination and contract services? Those were different techniques to make it so that alternatives had the same study period, so they existed over the same time frame. You have to apply those techniques when it's a mutually exclusive alternative, meaning that you're only going to pick one. In this case, you're not only picking one alternative. And for that reason, you don't have to do anything special to make the items last the same duration. So you don't have to have like a 400-year least common multiple to find out, what's the perfect ending point that all of these, after having cycled, stop at the same time. Don't do that. Just calculate the present worth of each alternative on its own. So for example, in the case of the projector, as a purchase price of $1,400, that's an outflow. It's going to have an additional net revenue of $890 per year. That's an inflow. And it exists over 6 years. So if the rate of return is 6.5%, discount those future revenues to the present, combine it with the outflow, and find out, is the present worth positive or negative? So you're going to do an initial screening just to see which of these alternatives maybe ought to be rejected because they don't have a positive present worth. So I wanted to clarify that point here in part A. The present worth analysis, in this case, because these are alternatives that multiple can be selected. You're not just picking one, you're picking whichever ones make sense up to the budget limit, then no need to do LCM, no need to do contract services or anything like that. So any questions?
For the test, are we going to have to do this by hand, or are we going to be using Excel? Or do you know what it was?
The test I haven't written yet, so I'm always reluctant to give too much detail about the test because what if I forget what I told you and then I make it a different way, But most of the time, like if I asked you to do this problem on the test, you could do it by hand or Excel.
Okay.
Like I think on a problem like this, I'd just give you the option.
Okay.
Yeah. Okay. So capital rationing, we've talked about this idea already when we were discussing cost effectiveness analysis. Remember when we were talking about how many different offices you'd maybe want to have open to process CDL applications? We were talking about Beckley and Huntington and Charleston, and the idea was that if you only have a certain amount of money, then you'd want to choose which organizations are the most efficient. So when we did that cost effectiveness analysis, we were talking about public sector projects. But it's not just public sector projects that face this idea of there being limits on how much money you've got available. For-profit organizations also have limits on the available investment capital. So, I mean, that makes sense. Companies don't have unlimited money, and neither do governments. So here are a couple of figures that illustrate some really fantastic projects that were built and considered when I was living over in the United Arab Emirates. When I lived near Dubai, there was the Palm, which is an artificial network of islands that have a luxury hotel, that have big homes, apartments, and so on. That just used to be the ocean, and they dug a bunch of sand off the bottom of the sea. They dredged it. They piled the sand up, and they tamped it down. They compressed it, and they made these offshore islands. Now, people live on these offshore islands, and it's really swanky, expensive properties. So they actually built it. They had enough money that they could make that happen. Another big project that was being built when I lived over there was the Burj Khalifa, which is the tallest building in the world. And it's just really a sight to behold. You can see it from really far away because it's so tall. But the Burj Khalifa was, as you might expect, very expensive to construct. They were doing new things that had never been done before. They had to build refrigerators for the concrete because concrete, when it cures, generates heat, and they wanted to build this tower more quickly than the natural rate that would have occurred if the heat was being dissipated on its own just by convection. So instead of just having set the concrete, let it cure, let it cool down over the course of a couple of days, they actually chilled the concrete with like a refrigeration system so that they could build each level a little bit more quickly. So that's expensive, not only when you're building a tall building, but when in the desert you have to build a refrigeration system to cure the concrete more quickly. So they did it. They built both of these, but they never did build the underwater hotel that they were talking about. That was something that you occasionally heard about from time to time in the newspaper, or a TV segment that they were going to have this fantastic hotel where the rooms, you could look at the fish in the rooms. That sounds really scary if you ask me, to be below the water surface, and what if it springs a leak? It sounds like a horror movie, but I suppose it would be definitely unique. But they never did it because I think they ran out of money. There was a little bit of an economic crisis that happened in 2008 that cooled off a lot of these projects when things were really cooking at their most furious over there. So when you have multiple options, then if you want to maximize your profits, you have to evaluate which are your highest priorities. And a capital budgeting study will allow you to identify which projects you should fund first, what are your second priorities, and so on. And it begins by generating cash flow estimates for each project, where you're going to try and summarize how much you expect it may cost, how much revenues can be generated in the future. Then in a capital budgeting study where you're trying to pick from alternatives, typically what we assume is that we either do a project or don't do it, but partially funding the project isn't an option. Like, you're not going to build just half of the underwater hotel. Water would rush in if you just decided we're not going to build that wall because we ran into budget limits, so we'll build everything but the final wall. It wouldn't work. Some projects actually can be partially funded, but instead of assuming partial funding on a project, what you do is you just generate a completely new alternative. You'd say it's an alternative with maybe, the building is 100 floors tall, an alternative where it's 110 floors tall. And they would be standalone alternatives rather than partially funding one of the discrete options. In a capital budgeting study, the constraints that your organization have could be related to the cost of acquiring capital. If you're going to be going to the bond market to raise money. Right now, interest rates are very high. And so it's expensive for companies to expand. It's expensive for companies to acquire new capital equipment, to build new factories, because interest rates are higher than they've been in 20 years. And so the cost of capital means that you only are going to move on the really profitable projects right now. That the kind of humdrum projects that are only going to make a meager return are a bit too risky to invest in additional spending. So through this process of a capital budgeting study, what we're trying to do is maximize the return on investment. And there's multiple alternatives. Remember that we have many different options. There's always somebody's got some pet project that they want the company to undertake. And so we have to evaluate each project just for its overall suitability, like on a yes-no basis. You know, we are using our minimum attractive rate of return, and we're finding out if the project has a positive present worth. If the project has a positive present worth, then it's potentially justifiable. But potentially justifiable doesn't necessarily mean it's going to maximize the return on investment when we have multiple alternatives. So even the case of the incremental analysis, which we talked about, incremental analysis wouldn't get us where we need to go. Because incremental analysis is simply telling us among alternatives which are mutually exclusive, which one is the best. And here it's a different story. It's not which one is best, which is the one we should do. Here, this study is going to be which group of projects should we do? Because there's going to be multiple options that they're not exclusive. You can do more than one of these projects, and just trying to find out which combinations of alternatives will generate the most amount of money. So our textbook presents this figure as kind of a summary of the evaluation process. And the idea here is that you have independent projects, and this independent projects, that's key terminology. This is maybe some lingo that you should learn. It's the opposite of a mutually exclusive alternative. Independent projects mean that you aren't just going to choose one, that you're going to do as many of them as you have budget for and as many of them as are economically justified. So you're going to keep spending until you run out of money or run out of ideas that are profitable. That's what independent projects means. So you've got all these different options. You've got option A, option B, option C. And you'll notice they last different useful lives. That's okay. That doesn't matter if it's an independent project. And if it's not an either-or situation, if all of them can operate in parallel, then we don't have to make the useful lives the same. But each one of them is going to have some upfront investment, which hopefully justifies itself through a sequence of profits over time. And what we know is that we've got a limit on how much can be spent. And so we want to find out, should we do A and B? Should we do A and C? Or should we do B and C? There's a certain number of options that can be selected. So in this case, if you have 4 alternatives, the number of bundles that there are is 2 to the m, where m is the number of projects that you're choosing from among. So this is the data that we're going to use for today's in-class exercise, and this is saying that there's 2 to the 4th bundles. So 2 to the 4th means 2 times 2 times 2 times 2. Okay, so that's 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 bundles. A bundle is just a combination of alternatives. So this is saying that there should be 16 different bundles. 3, let me write this on the board. 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So for example, one bundle would be only option A. That's one bundle. Another bundle is only option B. Okay, so C, D, that's a bundle. There's another bundle that is A and B together. There's another bundle that is if you did A and C. Now, A and C is the same thing as C and A. So that's not like two different bundles. If you just put the letters in a different order, what it means is how many projects are you doing and which projects are there. So let me give you this handout, and the first thing I'd like you to do is identify how many possible bundles are there. Well, I already spilled the beans there. It's 16, but what are the combinations? So see if you can write down on the paper all 16 possibilities that exist. It's trickier than you might expect. You need to be systematic about it. So you can work together, see if you can figure out all 16 bundles. What we're going to do next is easiest if we use Excel. So let's fire that beautiful program up. I'm going to define the budget limit as negative 23,500. So that's the maximum amount we can spend according to the handout. It says that we have a budget limit of $23,500. Okay, so just keeping that in mind here at the top, we're going to have bundle number, combination, cost, and is it possible within the budget limit? Okay, so we know that there's 16 of these bundles. So the combinations are A, B, C, D, A, B, A, C, A, D, B, C, B, D, C, D, A, B, C, A, B, D, A, C, D, B, C, D, B, C, D, and do nothing. The cost of them individually, negative 10,000 for A, negative 5,500 for B, negative 8,500 for C, and negative 15,000 for D. So this next part's going to be a little bit kind of annoying, having to click and all that. So let me show you a little shortcut that will work for us. Option A is $10,000 in cost, right? So that is in cell C6. Does everybody see how that $10,000 is in cell C referring to the column, 6 refers to the row? There's a little part here in Excel, the name box. Like that cell can have an alternate name besides C6. So we can assign it a variable. Like if I just wanted to call that cell A, I can give it a name A. And so down here when I do like AB, if I rename this one, if I call it B, then in my formula I can just do equals A plus B. And then it does the cost that way without me having to click in the location. And it's an anchored reference as well, which can be useful. So you can name C6, you can name it A. We could name C9 D, but we can't name this one, like variable C, because the column is already called C8, I don't think will let us name that just C. Like it doesn't work. So instead of that, maybe I'll name it SEE for C, you know? So this one is going to be A plus C, all right? A plus D, B plus C, and so on. It's just a little bit simpler, maybe. So find the cost of each group of alternatives. Does anybody have any questions so far? Do I need to illustrate how I renamed those variables? Over here in this top left side. Okay, so on the handout, we've done part A. We've done part B, which was the total investment required for each bundle. And then part C is, if we know the budget limit is 23,500, how many feasible bundles are there? So we want to count out the number of feasible bundles. So maybe what we could do is, if it's feasible, we can put a 1, and if it's not possible, meaning that if it's over the budget, we put a 0. So for example, 1, because option A is below the budget. If the budget's 23,500 of cost, what we're looking for is if something greater than or equal to that, then it's okay. So option A is okay, option B is okay, option C is okay. It's easy to make mistakes if you've got a really long list and we're coding this manually. So instead of relying on our infallibility, what we could do instead is we could write an if statement that automatically diagnosed whether it's possible. So let's give that a try. Equals if and parentheses. So we have to create a logical test. And what we want to know is this greater than or equal to the budget? Because think about this. This is negative values. So if it's more negative, it would be less than, and it's not possible. So I guess we could either do it as saying if it's greater than or equal to, then it's a yes. Otherwise, it's a no. So that would be if that is greater than or equal to this limit. I want to anchor that reference so that it's always looking in that cell. So it's greater than or equal to, then give it a 1. Otherwise, give it a 0. Okay, so it says like that this is possible. The next one it says yes, it's a 1. It's a 1. If I drag this down, like what's one that I know is right on the line? It's option CD. So is option CD acceptable? I see someone nodding their head. Why is it acceptable? Because it's right at the limit. The limit is acceptable. Beyond the limit is not acceptable. So if we drag this down, it should say yes to option CD. And it did. But it should say no for A, B, C, D. Because 24,000, that's too expensive. So if I drag this down, it should say, uh-oh, I've got a problem.
It's because your A is referencing the entire time. You need to change it to C.
Yeah, that's right. That's right. Okay. So it is, it should be not cell A. I should just have it do C6. Yeah, because it was locked on, okay, so if C6 is that, let's drag that down. Okay. All right, we've got some no's now where the cost was too high. Only drag it down the rest of the way. The reason why I did like 0 and 1 instead of yes and no, because you can have text be the result of a if statement. I could have had it return yes if it's possible. Is I want to count these because I'm asking how many possible bundles. And so if I sum this up, then this is going to answer the question 10. So there are 10 feasible bundles, meaning there are 10 bundles where the cost is at or below the limit. All right, let me do this if statement again in case you missed it the first time. Let me delete it. This time I'm going to do it as a less than, just for kicks. So equals if this cell C6 is less than the limit, then it's a 0, meaning it's too expensive. If it's more negative than 23,500, then it's not feasible. Otherwise, comma, it should say 1. So it's just the reverse of the logical statement that we had in that column before. So now if I drag that down, it's saying no for the one that's 25,000 because that's too negative, too expensive. It's this border case of 23,500 says that's okay, which it is. And of course, it's telling me that the do nothing alternative is economically feasible. And we've got 10 feasible bundles. Okay, so that concludes part 1. Any questions so far on what we've done with bundling? Okay, now on part 2 of the handout, it says capital rationing. And we're going to continue only with the acceptable bundles from above. And we want to find out what is the present worth of each bundle. So let's create a copy of this. Only has the feasible bundle. So I'm going to have bundle cost annual net cash flow. That takes up, that's kind of wide there. So I'm going to do wrap text here. See this button, wrap text? If I do that, then it doesn't use up so much width. Annual net cash flow, and then the last one we'll do the present value of the bundle. Okay, so which were my feasible bundles? There was A was feasible, B, C, D. There was AB, AC. Now, AD was not feasible, so I'm going to skip over that one. BC, BD, CD. I'm going to skip over ABC, ABD, ACD. Skip over all these, and then the do nothing, yes, do nothing is also feasible. So I've just only got my feasible bundles here. So for the cost, I can just refer to where I had it before. I think that'll work for all of them. But we're going to delete the rows that are not feasible. So I'm going to, it's doing that same thing as before. Well, labeling that A just got me more trouble than it was worth. Let me say it was C6. Now, drag that down. Okay, so I'm going to delete any of these infeasible options because they're over the budget limit. Annual net cash flow in the handout, it says for A, it is just 2,500. B is 1,300. C is 2,100. And D is 3,200. Okay, so I'm going to pause from talking and allow you to work through the rest of this. And so obviously for BC, the annual net cash flow is going to be the 1,300 plus 2,100. For BD, it's going to be 1,300 plus 3,200. So add that together, and then the present worth of bundle, what you're doing is you're finding the present value of the annual net cash flow. So that's find P given A, or in other words, use the PV function, and this amount in column I goes into the payment field, where the handout tells us each alternative has a useful life of 8 years, according to the handout. Our interest rate is 12%. So let me put that at the top as well. N is 8. I is 0.12. We're going to refer to those when we calculate the present worth of the bundle. Let me pause and give you a moment to calculate that and work independently.
How did you get the annual net cash flow with the PV?
Well, the annual net cash flow is just given on the handout.
Oh, it's on the handout.
Yeah.
Well, build a building and then throw a turret in, but you can't pull back the ocean, build a building and throw it back. So I can see it.
Okay, so the present worth of the bundle is we want to find the present worth of the revenue using the PV function, and then after the PV function is finished, add in the cost, which is already at the present. So you'll notice here in this equation, which is pretty small, basically what we're doing is the present value and the annual net cash flow is going into the PMT field. Don't use the double comma, because if you use the double comma, you're telling the program that there's this single payment 8 years in the future and you want to know the present value of that. And that's not the situation. The situation is that there's a recurring payment that happens 8 years in a row, and you want to find out what's the value of that sequence. So that's why we put the annual net cash flow into the PMT field. And then outside of the function, we do plus the cost. So remember, we do have to put the minus sign. So what's the best option? Should we do nothing, or can we do better than zero profit?
AC.
Yeah, we should do AC. It's the most profitable. If I highlight all of these options, Excel is just really acting a bit strange. If I highlight all of these options and I do the conditional formatting, I'll have it highlight the greatest one. Where's the, oh, top. Yeah, so the more rules. Maybe I can have it do the top one. And so it's going to highlight it. I didn't tell it what color. I'm not really great with conditional formatting. I'll do it manually. It's this one. This is the most profitable. We should do option AC. Option AC is how we maximize our profits. So ironically, it wasn't the most expensive option. There were other bundles that were more expensive, but still within the budget. Like we could have done CD, but it doesn't generate as much profit. So your homework assignment is very closely related to this. If you save a copy of what you've done in class today, I think you'll find that as a useful reference as you finish problem 3 on the homework. If you didn't quite click today, the video will be there on YouTube, so that's a resource for you as well. Before we go our separate ways, just keep in mind that the assignment is due before class on Monday, and then also you should be thinking about the project. Open up the file, start playing around with the calculations. Just get started and it'll finish itself. Give yourself the time. All right, see you on Monday.